Title: Reproducibility Study of ITI-GEN, Inclusive Text-to-Image Generation. Abstract: This study aims to reproduce the results presented in ITI-GEN, Inclusive Text-to-Image Generation, by Zhang et al. 2023a, which introduces a model to improve inclusiveness in text-to-image generative models. The authors claim that ITI-GEN improves the diversity and quality of generated images, is scalable to different domains, has plug-and-play capabilities, and is efficient from a computational point of view. However, ITI-GEN sometimes uses undesired attributes as proxy features and struggles to disentangle some pairs of correlated attributes such as gender and baldness. This study verifies these claims and proposes using hard prompt search with negative prompting to solve these issues. Introduction. Generative AI models that solve text-to-image tasks pose societal risks related to fairness due to training data biases. Zhang et al. 2023a introduce inclusive text-to-image generation, ITI-GEN, a method that generates inclusive tokens that can be appended to text prompts to ensure diverse images with respect to predefined attributes. Scope of reproducibility. The authors make several claims about ITI-GEN, including its ability to improve inclusiveness while preserving image quality, scalability to different domains, plug-and-play capabilities, data and computational efficiency, and scalability to multiple attributes. This study aims to verify these claims through experiments and also studies failure cases of ITI-GEN and proposes alternative methods that handle negations in natural language. Methodology. The authors provide an open-source implementation on GitHub, which was used as the starting point for this study. Bash scripts were designed to make the experiments reproducible. The integration of ITI-GEN with ControlNet, Zhang et al. 2023b, was also implemented to check the compatibility of ITI-GEN with other generative models. ITI-GEN is a method that improves inclusiveness in text-to-image generation by outputting a set of fair tokens that are appended to a text prompt to guide the model to generate images in a certain way. The model uses reference images for each attribute category and learns a set of fair tokens that represent each attribute category. The training procedure involves two losses: the directional alignment loss, which relates the provided reference images to the inclusive prompts, and the semantic consistency loss, which acts as a regularizer by making the original text prompts similar to the inclusive prompts. The directional alignment loss is defined as the difference between the average of image embeddings between categories of an attribute, and the difference between the average of embeddings of inclusive prompts corresponding to those categories. This loss is replaced by a cosine similarity loss when it is undefined. The semantic consistency loss makes the original text prompts similar to the inclusive prompts. At inference, the output of the generative model reflects the attribute categories of the fair tokens. Sampling over a uniform distribution over all combinations leads to fair generation with respect to the attributes of interest. The text prompt can be the same as used for learning or different. ITI-GEN is compared to HPS, which works by specifying the categories directly in the original prompt. However, HPS does not handle negation properly, and using a prompt like, "a headshot of a person without glasses," will actually increase the chances of getting someone with glasses. This can be circumvented by using the unconditional underscore conditioning parameter, which is hard-coded to take in the empty string in the current stable diffusion sampler. The authors provide 4 datasets of reference images to train the model: Celeba, Fair, Fairface, and Landscapes HQ. The hyperparameters used to reproduce the results of the original paper are provided, and the code used to replicate and extend the experiments is available on GitHub. The experimental setup and code are also described, including the implementation of ITI-GEN with ControlNet to validate its plug-and-play capabilities with other text-to-image generation methods. The research paper discusses the evaluation of ITI-GEN, a text-to-image generation model, focusing on its inclusiveness, image quality, and scalability. The authors investigate the model's performance across various attributes, including skin tone, eyeglasses, and mustache, using the Celeba dataset. They compare ITI-GEN with HPS and HPSN, analyzing the KL divergence for inclusiveness and FID scores for image quality. The results indicate that ITI-GEN outperforms HPS in terms of FID scores, suggesting better image quality. However, human evaluations show a preference for HPS in 52.24% of the cases, highlighting a discrepancy between the FID scores and human perception. The study also demonstrates ITI-GEN scalability to different domains, such as natural scenes, and its plug-and-play capabilities with similar prompts. The computational requirements are discussed, including the use of an NVIDIA A100 GPU and the Snellius infrastructure, with an estimated CO2 emission of 6 kg. The paper concludes by supporting the first 4 claims of the original paper but not the last one, emphasizing the need for further investigation into the model's limitations and future work. ITI-GEN, a machine learning model, is designed to generate diverse images based on textual descriptions. The model's capabilities are demonstrated through various experiments involving different domains such as human faces and natural scenes. In one experiment, ITI-GEN was used to learn inclusive tokens for age and gender using the text prompt, a headshot of a person, with the Celeba dataset. These tokens were then applied to other similar text prompts, resulting in diverse images but with slightly diminished quality. Additionally, ITI-GEN's compatibility with ControlNet was tested, showing that it improves diversity with respect to the inclusive tokens used. However, it may introduce other biases from the reference images, such as hair color or clothing style. The model's data and computational efficiency were also verified, with training taking less than 5 minutes and generation taking around 2 seconds per image. Scalability to multiple attributes was tested, revealing that while the KL divergence is low when using 2 attributes, it increases significantly when adding more attributes. This suggests that ITI-GEN's claim of scalability is not entirely correct. Further investigation into this observation is conducted qualitatively and quantitatively in the following section, where more pitfalls of ITI-GEN are highlighted. In another experiment, ITI-GEN might use proxy features while learning inclusive prompts for certain attributes, such as using gender as a proxy for attributes like bald, mustache, and beard. This can lead to strongly coupled attributes and inaccurate image generation for all elements in the joint distribution. HPSN, on the other hand, is able to disentangle these attributes. The reason behind this issue is hypothesized to lie within the reference images, which may lack diversity and cause the model to use gender as a proxy. An experiment using 2 variants of the eyeglasses dataset further supports this hypothesis, showing that ITI-GEN can correctly handle the combination of gender and eyeglasses attributes when using a diverse reference dataset but fails when the dataset is altered to entangle both attributes. The paper discusses the use of proxy features in image generation models, specifically focusing on the ITI-GEN and HPSN methods. It highlights how these models can learn to generate images based on certain attributes, but may also use proxy features that are not intended. For instance, when generating images for the bald attribute, ITI-GEN uses gender as a proxy feature, resulting in all positive samples being men and all negative samples being women. This issue is resolved by using HPSN with negative prompting, which accurately generates bald women. The paper also explores the challenges of handling multiple attributes and diverse image generation. ITI-GEN struggles to generate diverse images, particularly when dealing with attributes like age and eyeglasses. On the other hand, HPSN reliably reflects all category combinations. The authors propose combining ITI-GEN with HPSN to leverage their strengths, achieving a KL divergence close to 0 and a FID score comparable to ITI-GEN's. Furthermore, the paper presents an ablation study on the diversity of reference datasets for the eyeglasses attribute. It demonstrates that the choice of reference images is crucial, as the model might not learn what is expected but rather the most salient difference between the datasets. The computational complexity of ITI-GEN is also discussed, highlighting its linear complexity with respect to the size of the training set, quadratic complexity with respect to the number of categories within an attribute, and exponential complexity with respect to the number of attributes. The research paper discusses the validity of claims made in the original paper regarding ITI-GEN's capabilities. It highlights ITI-GEN's ability to generate diverse high-quality images across multiple domains, including human faces and landscapes, with low KL divergence and FID scores. The paper also explores ITI-GEN's plug-and-play capabilities with different text-to-image generators and its efficient training process. However, it notes that ITI-GEN struggles with scalability to multiple attributes, requiring exponential training time and often failing to disentangle certain attributes. To address these limitations, the authors propose HPSN, which does not require training and produces more accurate images. The paper concludes by emphasizing the importance of considering potential risks and biases in ITI-GEN's use, particularly regarding data privacy and inclusiveness. The paper discusses the development of ITI-GEN, an inclusive text-to-image generation model that aims to address the issue of bias in image generation. It is trained on a dataset with diverse attributes and uses a novel approach to ensure balanced representation across different attributes. The model's performance is evaluated using KL divergence, which measures the difference between the generated images and the target distribution. The results show that ITI-GEN outperforms baseline models in terms of diversity and inclusiveness, particularly for attributes like gender, hair color, and facial features. The model also demonstrates compatibility with ControlNet, another text-to-image generation model. The paper provides an extensive list of references, highlighting previous work in this area and related fields such as machine learning, artificial intelligence, and computer vision. This includes research on diffusion models, vision language models, and the quantification of carbon emissions in machine learning. In conclusion, the paper presents a significant advancement in the field of text-to-image generation, focusing on the critical issue of bias and inclusivity. The development of ITI-GEN contributes to the creation of more diverse and representative images, which is essential for various applications in computer vision and beyond. The research discusses the ITI-GEN model's ability to generate diverse images based on specific attributes such as skin tone, age, and facial features like beard and mustache. Page 15 highlights the model's compatibility with ControlNet, showcasing improved diversity in images generated for different conditions. It also presents examples of proxy features used by ITI-GEN. Page 16 delves deeper into the model's performance on attributes like gender and facial hair, demonstrating its ability to use gender as a proxy for beard and mustache. The results indicate that while ITI-GEN struggles to generate women with beards, it performs well with the combination of gender and mustache. The study emphasizes the model's low data requirements, showcasing improvements using only a few reference images. Overall, the research demonstrates the ITI-GEN model's capabilities in generating diverse images based on various attributes, highlighting its strengths and limitations in specific areas. In the Transactions on Machine Learning Research, published in June 2024, a study explores the impact of reference dataset size on improving diversity in generated images using ITI-GEN. The researchers investigate how varying the number of reference images affects attributes such as age, skin tone, and colorfulness. Figure 11 illustrates the results of this investigation. For each attribute, the study compares the diversity achieved with different sizes of reference datasets, specifically 10, 25, and 50 images. The findings suggest that ITI-GEN can effectively enhance diversity even when using a limited number of reference images. The age attribute shows a noticeable improvement in diversity as the size of the reference dataset increases from 10 to 50 images. This indicates that a larger dataset can provide more comprehensive coverage of age-related features, leading to more diverse age representations in generated images. For the skin tone attribute, the results demonstrate a significant improvement in diversity with just 10 reference images. This implies that ITI-GEN is highly effective at capturing and generating diverse skin tones, even with a small dataset. Lastly, the colorfulness attribute, tested on natural scenes, also shows an increase in diversity as the reference dataset size grows. This suggests that a larger dataset can help ITI-GEN better understand and generate a wider range of colors and textures, resulting in more diverse and natural-looking scenes. Overall, these findings highlight the potential of ITI-GEN to improve diversity in image generation tasks, particularly when working with limited datasets. This could have significant implications for applications requiring diverse and inclusive image datasets, such as in advertising, media, and AI research.